All right, guys. So 6.1 is all on rational exponents. So we just did a huge review on chapter 6, like a preview on exponent rules. So my suggestion for you is to keep those handy at all times. And we're going to continue kind of incorporating a lot of those different rules into solving our rational exponents. So a couple examples. Part 1 is writing radicals in exponential form. Samples. Well, you know, if I were to give you, let's see here, the square root of 9, that it would be plus or minus 3, right? Because 3 times 3 is 9. So technically, when I say the square root, there's an invisible 2 here and a 1 after the 9, okay? So you'll see here that the square root of 8 can actually be written as 8 to the 1/2 power, okay? Or the power of 1/2. So for this next one, the fifth root of 30 is actually 30 to the 1/5 power. Okay, the cubed root of 4 to the second, or 4 squared, is 4 to the 2/3 power. Okay, so the sixth root of 7 cubed becomes 7 to the 3/6, or 7 to the 1/2 power. So some of you are noticing the pattern here. It says you will notice that the numerator, or the top of the rational exponent, is the power of the radicand, stuff inside the radical symbol, while the denominator is the root. Huh? In other words, this number on the outside of your like square root sign, okay, or your root sign, always is the denominator. Okay, and the number on the inside, so this 2, is your numerator. All right, so you'll see here, we took this 2 and made it 2/3. We took this here, made it 3/6, which simplifies to 1/2. So let's try these. The square root of 13. Well, we know there's an invisible 2 outside and a 1 inside, so that's 13 to the 1/2 power. This next one will be 3 to the, let's see, ooh, that one's harder. 3 to the 4/3 power. All right, this next one will be 4 to the 1/3. And I want you guys to go ahead and try number 4 on your own. So you're going to do that one on your own. All right, down below, it says solving equations using exponents. In order to solve equations using exponents, until you reach algebra 2, the topic of logarithms, you must have the same base before solving. The idea here is same base. Okay, so let's go over a couple examples. What I want you guys to do is copy it down first, each problem down first, pause the video and rewind it and watch it again. Okay, so copy it down, stop the video, and rewatch. So we learned earlier when we were reviewing exponent rules that if we have the same base, or the same big number, and we're multiplying, then we can add our exponents together. So hear me out. Here we have a 5, and a 5. Those are the same big number, or the same base. So what I can do is take that 2x over 3 and add it to the x over 6, and that equals 2. Well, now if I'm solving this for x, I'm just going to try and get the same bottom number. To do that, I'm going to multiply this by 2. So I'll get 4x over 6 plus x over 6 equals 2. I can simplify now. I get 5x over 6 equals 2. All right, now I can multiply both sides by 6. I get 5x equals 12, and divide both sides by 5 to get x equals 12 over 5. So what we're doing is we're taking all those rules that we've reviewed last week and applying them to solve for our x. Okay, so for number 2, I know I have the same big number. I have 8 for both sides. Okay, well, we learned one of our exponent rules is if we're dividing, we could subtract, right? The opposite of multiplying is dividing. So number 1, we added. Number 2, we're going to subtract. So here's what I have. 4x plus 10 is equal to 3x over negative x minus 14. I want to solve for x, so I'm going to do 4x plus 10. Since I'm dividing, we learned with exponents we subtract. So I have 3x minus negative 2x minus 14. I'm going to solve. I get 4x plus 10 equals 3x. When I distribute this negative sign, plus 2x plus 14. Find your like terms. We get 4x plus 10 equals 5x plus 14. Solve for x. I'm going to subtract 5x on both sides. So I get negative 1x plus 10 equals 14. Subtract 10 on both sides. So I get negative x equals 4. X has to be -4. All right. All right. So for number 3, looking at number 3, they have the same base. Okay. They have 12 as their base. My next thing I need to be thinking about is, okay, well, what rule is being applied? And I'm dividing, so that means technically I'm subtracting. So let's go ahead and do it. 4x minus 1 minus, in parentheses, I'm going to do 2x plus 5 equals 7. Distribute that negative sign. I get 4x minus 1 minus 2x minus 5 equals 7. Combine your like terms. I get 2x minus 6 equals 7. I'm going to add 6 to both sides. I get 2x 13. So x has to be 13 halves. All right, so just applying what we already know about our exponent rules to solve for x. All right, so for number 4, I'm going to have you guys do number 4. Remember, we have the same base for this one and we're multiplying. So what was my rule with that? Well, if I'm multiplying exponents, I add them together. So I want you guys to think about that and solve for x on your notes. Okay, number 5 switches gears. Number 5, we don't have the same base. So I need to think about, okay, how can I get these to have the same base? So here I have 2. For this other one, I need to figure out a way to make this 8 a 2. So how can I do that? Well, I can write that as 2 to the 3rd power. All right. So I have 2 to the 6x plus 1. Since I raised this to the 3rd power, I'm now in parentheses going to have it to 3x minus 4. Now I have the same base. All right, but watch what happens. Because 2 times 2 times 2 gave me 2 to the 3rd, or 8. Now I have 6x plus 1 on the left-hand side because I'm getting rid of that base. But I need to bring over this 3 times 3x minus 4. So I get 6x plus 1 equals 9x minus 12. Solve for x. I'm going to subtract 1. I get negative 13. I'm going to subtract 9x. I get negative 3x. Okay, divide both sides by -3. I get x equals 13 halves. Okay, so trying to get these to have the same base. So for number 6, all right, we have 9, and then we have 243. So for this, you might need to use your calculator. All right, so I'm thinking in my head, how can I get 243 to have the same base as 9? Well, I know 9 to the 2nd is 81. 9 to the 3rd would be 279, so 9's not going to work. So I know then that 9 can be broken down to 3 to the 2nd power. Okay, so I'm wondering if there is a way I can get 243 to have a base of 3. So 3 to the, let's just say 5th, well, there we go. 3 to the 5th power is 243. So I'm going to say 3 to the 5th. I need to multiply that, though, by x minus 11. When I do that, I get 4x equals 5x minus 55. I'm going to subtract on both sides. And I get negative 1x equals negative 55, so x is equal 55. Ooh, sorry, computer's freaking out over here. Let's take a look at 7. So in my head, I'm thinking about 8. 8 to the 2nd power is 64, so I need to be able to break both these numbers down farther. I know that 16 can break down to 2 to the 4th power, and 8 can break down to 2 to the 3rd power. So I get 2 to the 4th times that 4x minus 5 is equal to 2 to the 3rd, which is x plus 8 in parentheses. I have the same base, so I'm going to multiply what's in parentheses. I get 16x minus 20 equals 3x plus 24. Solve. I'm going to add 20 to both sides. Subtract 3x on both sides. I get 13x equals 44. So x has to equal 13 over 44. All right. We are going to call that the, you know what? I'm going to have you guys actually try. We're going to skip number 8 and 9, and we'll do that in the next video for part 2. But I want you guys to go ahead and try 11 on your own, and I'm going to hop in on 10 in the next video. Okay? So we'll do 8, 9, and 10 in the next video.